All right, so let's take a look at some of these later projects. In particular, the SQL injection probably requires a bit of explanation. So this page has got several different SQL databases on it. And so the first thing is, if you don't know structured query language, you have to learn basically how it works. So here you can just execute SQL commands right here on the database. So for example, you can show databases. And this is, of course, something that you would only let an administrator do. So there are two databases here, one called information schema and one called widgets. Now this is MySQL, and all SQL injection requires you to know what you're asking for. And it's easier than you would think because it automatically creates certain objects that have predictable names. And MySQL always creates this information schema database that contains the internal information. So you can look in there to find out the other names. So there's a company here and they've got a database called widgets. So if I show tables, I'll see all the tables in here, and it shows me the tables in widgets because I didn't specify which database, and it went with the default database. Now you can select constants. You do not need to select data from databases. You can just select constants, constant strings, and then it will just return one record, that record containing one. Anyway, you can do strings and substrings, and those will be important later. But let's go on to this one. If I want to see all the information about the employees, and I know the name of the database, and I'm in the right, if I'm in the right database, and I know the table, I can select the information from the employees, and here I see names of employees and social security numbers. All right. And you can do a lot more here, but if you didn't know the name of this table, employees, you could find out by using queries like this one. This will give you a list of all the tables in the database. So let me get it somehow. There we go. There. And so now I'm getting all the information from all the tables in the information schema database, and it is a very long list of things. And it names automatically generated objects with capital letters here, just to make it easier to spot them. So here you can get a list of all the table names present. And again, you see many, many automatically generated tables, but the ones specific to the company are typically lowercase, and so that's where you can get the fact that the main table is named employees. And here you can get all the columns, and this will show you all the columns in all the databases. So you can, let's bring that one up. And again, there'll be a long list of automatically generated ones in capital letters, and down at the bottom, the columns in the special database designed for the company, ID, name, and SSN. So this is the sort of stuff you can do as the administrator, and there's a couple flags to find here using some of those queries. So now we can do SQL injection. In SQL injection, you don't have the ability to execute a select query directly, of course, because they'd only let the administrator do that. What you have is something like a login or a search field. So if I search here for a name of someone that's really in the database, I'll find it. By the way, this page has several different SQL databases. When you see these horizontal lines, they tell you when the database changes. So the 100 queries challenges have one database, so you can't assume any information there applies to the next one. And I see in the chat, someone wants me to add you to the workshop channel. I can't do that. You'll have to go, what I did was go to the LobbyCon and ask an administrator to add you. I don't have the ability to add anyone on the Discord, but I can let you in the Zoom and the class materials here because those are under my control. All right, so the point of SQL injection is if you input, if I look for someone who's there, it will find that person who's there. But if I look for another name with an apostrophe in it, I will get a syntax error. And what that means is it's the same thing as all these other command injections. It means that I have somehow put in data and I've confused the server about whether this was a command or data. So what I did was I put in the name Tip O'Neill. Let me make this big for the people that may have low resolution connections. So I put in the name Tip O'Neill, but unfortunately that has an apostrophe in it, and the developer put in this code, and the apostrophe matches the apostrophe I put in. Now this is a terrible thing, and it's just like all the other ones we've done in this section. I'm taking data from the user and I'm putting it in a line of command line, which is then parsed as if it had been typed in by the administrator. And that is a very dangerous thing to do. So it matches tip O for the name, and then it expects a SQL command here, and it finds Neil, and Neil is not a valid SQL command. And what that means is I'm able to inject data, which is interpreted as a command. And this is the general pattern of everything we're doing here. You do fuzzing, or you just send garbage to a server until you find a crash where something breaks. And then you've got a denial of service attack. And the whole point of exploit development is to improve a denial of service attack up to remote code execution. So right now, we can cause an error. And that means if we put in a more careful injection, like this one, we can do something other than create an error. And so this one will give me all the names, because now it says name equals Sam or 1 equals 1, and then the pound is a comment character, so it eats that extra apostrophe. So instead of just having a syntax error, I now have a perfectly valid command which will tell me all the names equal to Sam and all the other names, because this condition is always true. So by carefully crafting these SQL commands, here you can dump any information that this query was intending to give you. And if you want to see other information that the developer did not intend for you to see, you can use union to add a second entire select command to it. So here, I look for names equal to Sam, and there aren't any, and then I select one, so I'm able to run an entire select query of my choice. So this injection means I've taken this box and I've effectively turned it into this box where I can inject anything I want. All right, so you can find social security numbers and passwords. The pros mostly use SQL maps, so you can try this if you like. If you have a Kali machine or you want to use your other Linux server, you can try a couple of SQL maps. One of them goes through a Cloudflare firewall, which blocks some of the simpler SQL map attacks. And all right. And then I got blind SQL, which is a kind of fun logic problem. So I'll reset the server. Good thing to do now and then. So here I have the same thing. If I search for a name that's in the database, I'll find that person in the database. But I might imagine, all right, now let's try this. If I search for X, I have no result. So it printed the name if it found it, but it prints no result if it doesn't find it. Now, if I try to print out everything with this one, then you can see what happened here. Select name from employees, where name is X or A equals A. Now here I didn't use the comment character, but just a carefully crafted name with 4 apostrophes in it, so the number of apostrophes would still match. So this should have dumped all the names, but it didn't, because this is blind SQL injection. Instead of printing any of the results it got from the data, it just echoes back your question. If it found it, it echoes back what I asked for. So I do not see any data that came from the server at all. So if I want to find the data that's stored in the database, I have to get it indirectly. And so you can ask questions like this. So now I know if I ask a question and it's true, it'll echo back what I put in. If I ask a question that's false, like A equals B, then I get no result. So I can ask one yes or no question. If I get no result, the answer is no, this condition is false. If I get a result, the condition is true. So I can now ask 20 questions. So if I wanted to find the name of the database, I could ask if the name of the database is equal to 1, this way. And I get no result, so it is not equal to 1. So I could try equals 2, equals 3, or I could start jumping around. If it's not equal to 1, it's probably greater than 1. And that is true. So I can track down the length of the database. And then if you go back and look at the earlier part, you see how you can pick letters. So you can slowly build your way out and find names and pathways. And so that's the game. Here's other ones to try. You can go for name, substring of name1 equals B. Let's try this one. This is the more complicated one where I add an entire select database, select command here. So it looks for the name X, and then it adds a whole second select. It's going to look for names where name equals Bill Gates, and the first letter of the name equals B. So this is true. I get a response because the first letter of Bill Gates is in fact B. But if I was to make this C, then it would be false. So you can ask questions one by one. And by the way, you can use greater than and less than on letters too. So anyway, you can now find various things in here by doing blind SQL injection. And that's the SQL injection challenge. Then there is Windows command injection. This is injecting into a Windows command shell. So down here, I've got a thing that prints out directories. So if you give it dot for the input, it will show you the contents of the default directory, which is here, showing various objects in there. And so you can add other things like who am I, dot and who am I, and it will print out the directory, and then it will tell you you are the administrator. This is probably why this one keeps going down so often. This time you're actually running with this thing called XAMPP, which runs a web server as administrator. So you got Windows administration command, and you can now dump file, write contents to a file, and so on. And there are some flags to find on here by executing those commands. All right. And the last couple are really good, clean fun. Server-side template injection. This one took me a long time to get working, and I learned it from a single tweet. Let me just close my curtain here. There was a tweet where people were putting out their favorite server-side template injection targets. And I've got one set up to use. Here you set up your own, but I'm running a vulnerable one here. So as long as it's still up, which it looks like it is. Okay, so what this is a modern web page. You can probably tell from looking at my materials that I don't do much in the way of modern web page design, but this got my attention because it has a fun vulnerability. So here I can search for users. So I could search for Fred and search, and it will tell me Fred exists. There is no actual database. It always tells you Fred exists. But the point of server-side template injection is you can make a sort of form letter that specifies what people are supposed to see. And you can use meta characters to put them in. So we're going to start with fingerprinting. So normal search, it just tells you Joe exists. In server-side template injection, you use the curly braces as a meta character to indicate other things like calculated fields and things that will fill in. So if I put that in, that brace 2 times 2, brace, when I search, it tells me that is 4. So it evaluated the contents in there. And this is by design, although they probably did not intend for me to do it. This is what it's intended to do. So now you can fingerprint the server. And here's some recommended injections. There are several common engines used for this. And you can try these different injections. And if the injection is evaluated, you follow the green line. And if the injection fails, you follow the red line. So let's try this one. Dollars curly brace, 7 times 7. And only one set of braces. All right. If I do that one, it does not evaluate the expression. It just echoes it back. So that is not the correct syntax for an injection here. So that means I'm on this path. And so you can fingerprint this server and find out what it's running. And on you go. And then you can try this one. This is a text multiplication instead of a numerical multiplication. And now you can really have fun. If you go to your Google Debian server, you can start seeing how Python 3 works. This template injection runs on Python 3, and Python 3 is mind-blowing because it is object-oriented, and you can use the class method to see what members of the current object are there, and you can move up the directory tree. So you are able to walk up the hierarchy, class, class, and base, right up to the root of the entire object tree. So if I have control of something like a string variable that I'm using in a search or something, I can add class to it and class, class, and class base to get to the root of the hierarchy. And then I can come down to the catch warnings method, and I can use that to import another library that the developer did not import into their project. And I can therefore find any Python 3 command in any library and execute it, when all I was supposed to be controlling was a text field. So it is bloody wonderful, but the commands you inject get kind of long, like those SQL injection commands. So you have a string, and then you have class, base, subclasses, and eventually you will have an exploit that lets you do whatever you want on that server. So this is a good fun. You can get remote code execution by server-side template injection, and it gets to be these long injections like this to make it up to the top, and you can eventually find all the methods you can inject. Anyway, it is very wonderful. Just like all the other ones in this section, you can execute arbitrary commands on the server. And there's another one here with a PHP vulnerability where you can inject. So that's the general world of command injection. And I want to tell you about the binary exploits for Linux, but I guess I'll give you another 15 minutes or so to work on things before we do that. So I'm going to stop this recording.